Hello, my friends of Atari Labs. Welcome to this webinar. This webinar is on the coupling of local geological data into Model Muse with Python and Aquifer App. So what we have done is that we have some geological information, and on the description of the video, you are going to find the zipped version of this folder. Please place this folder here on the webinar on your documents, okay? And what is on the what is on the what is on the folder is, if we open with QGIS, yeah, we have some drill points. Okay, so here we have some drill points. We have the area of interest, and then we have the refinement. Okay, so what is the history of that? Okay, so we have some in the field, we have some drilling points. Okay, and then we have identified how many points? We have identified 5 layers, okay? And these 5 layers could be sand 1, sand 2, will be lime, sandy loam, whatever type of soil that you have, okay? And in these were identified in the 8 drills that we have on the field. Okay, so, and from that you have created a shapefile. Okay, that is okay. And then we have also created a model that is a simple model because it's just the geometry. Okay, this is just the geometry. Okay, this is just the geometry where we have the AOI and the reference. Okay, okay, so where we have the total area and whether it's the refine. Okay, if you have understood through here, please type 1. Okay, great. So here we have the geological information on the shapefiles, and then we have as well 2 shapefiles that define the area of interest and the refine. Okay, so why we are going to couple just local geological data? Because on the extension of the model, you are going to find information just on some parts of the model. Okay, you are not going to have information in the whole model, and in the most of the cases it is like this. Okay, could be other places where you have more information in this around where you want to model. Okay, and that is why we are going to create a model just of this of the refinement zone. Okay, otherwise, okay, if you are here, if you are following me through here, please type 2. I want your questions. Okay, I really want your questions, because if you have understood what is my premises, okay, you are going to apply that for your own you are going to apply that for your own cases. Okay, if you have not understood the premises that we are talking about, when you want to do it by your own, that will be okay. So we are going to make a geological model just in this extension, and then we are going to apply the hydraulic parameters based on the geological model. Okay, just here. Okay, while for the other parts it will be just a default value. Okay, great, that is great. Okay, so with that we are going to start. Okay, with that, just to tell you that the geological model that we are going to create is just here on the extension of the on the refinement. Okay, and in the other part it will be just a default. Okay, There is a question that says how many points do you need per area, for example, drilling. In Gempy, I think that there is no minimum value, okay? Yeah, and that is 5, 8, okay? That really depends also on the budget that you have, okay? Let's see, with 5, 8, you can do it something decent, okay? However, this is not a technical, this is just a subjective point of view, okay? Great. Any other questions? Yeah. So let's start with Anaconda. Anaconda prompt. Okay. Actually, I did this exercise in Visual Studio. Yeah. Because I don't use, that is something funny, I don't use Anaconda more. So often later on, I don't use Anaconda that much because I'm more, some months ago, I shifted to Visual Studio, but yeah. But if you are learning, Anaconda is a great play. It's a great software to start. Okay, so CD documents, CD webinar. Okay, and then we type Jupyter Lab. Great, great, great. If you are here with me, please type 3. If you are here with me, please type 3. Okay, so here we have, okay, so here we have the CSV, we have the model, we have the shapefile, rasters, and the scripts. So let's open the scripts, okay? And here, let's see in part 0, okay, part 0, kernel clear allow, kernel and clear allow, okay, great. Okay, I have just restart the kernel and clear out, okay, great. So first, we are going to import GemGIS, NumPy, GeoPandas, and Matplotlib. Okay, if you don't have that installed, just follow the video. Okay, you just can install pip install GeoPanda, pip install GemGIS, pip install something. Okay, so we are going to open the reference. Okay, and the reference is this one, is this part. Okay, so we are going to open because the model will be created on the extension of the shapefile. Okay, so if you have the model bigger, so you will have to extend this shapefile. If you want the model smaller, you can also do it smaller. Okay, and then we have the coordinates. Okay, and in this case we have x min, x max, y min, y max. Okay, then we open the drill points as GeoPandas. Okay, so we have X, Y, and then layer 1, layer 2, layer 5, and the geometry. If you are here with me, please type 4. Great, that is great. Okay, so we can plot, and this is just a plot from GeoPandas. Okay, so this is just a plot from GeoPandas. Okay, and then we can interpolate, and this is where GemGIS comes. Okay, with GemGIS, you can give the GeoPandas data frame, okay, and then you can give the column, and it will interpolate that column in the extension of the refinement. Okay, understood? Yeah. So here we do a interpolation with GeoPandas, okay, and then we can see a visualization of our interpolation, and this interpolation actually is done with GemGIS, okay. Yeah, it's done with GemGIS for the bottom of the layer 5. If you are here with me, please type 5. I want your questions, please. I want your questions because this will enrich the. Well, only Jadon is actively on the chat. Anyone else? Mohammed? Anyone else? Well, let's see. Okay, so then we create a function because we want to create the okay, the rasters or the arrays we wanted to create it for every layer. Okay, so for every layer we have we create a function and then we do it for every layer, and then this will save us as a, okay, we can export that as a Python file, as a, no, as a TIFF, as a raster data file, but we can also export that as a NumPy file, okay, just keeping the array. Okay, so in this case we are just going to create the raster, and here, okay, it's creating the raster, and in this folder it will have stored all the arrays as a NumPy file, as an all the arrays for the bottom of every layer as a NumPy file. If you are here with me, please type 6. Who else? Great. So let's see. Okay, so that is for part 1. Let's see, and let's go for from part 0. Let's go to part 1. Okay, kernel clear and outputs. Okay, we import as well just Panda, Rasterio, Fiona. Okay, we open. Okay, we also open the model ref. Okay, we get the extend. We also open the drill points. Okay, and then we get the layer columns, and then we generate, okay, we generate a list of the x, y, and litho values. Okay, so here we have the layer columns. Okay, yeah, and this one, this for every x and y and layer, okay, we are going to have one row in, because this is the input for Gempy. Okay, this is the input for Gempy. So for example, and then every 4 rows we have the x, y, and z, and the bottom of the geological unit. Okay, great. And then for example here, that is what we have, and then we create pandas data frame, and then we store that as a model surface.csv. Okay, if you are here with me, please type 7. Okay, and then we have and then we are going to work with we have the x and y, and then in Gempy we need as well the contacts, and then we need the orientations. Okay, so we have, okay, there is a problem with the orientations, because if you want to, for example, we have 8 drills, and then we have for every layer we have 8 points, and then we have 4 layers, and this is 40 points. Yeah, but for the orientations, if you give 40 orientations, that will be an issue, because the code could get a little bit slow. Okay, and that is why we only take 3 from the 5 points. We only get 3, and these 3 points are random. And why I do take 3, and then later on I'm going to do another filter, because I'm going to do that because the layers are not horizontal, but they are not so vertical, or there are not some displacement and so on. So that is why, in case that your layer is critical and then you have to define, for example, an anticlinite, synclinite, a fold, or so on, then you have to place the orientation more proper. But in this case, since we are working with sedimentary layers, there is not such a hurry to implement all the orientations or the specific orientation. If you have understood that, please type 8. If you have understood that, please type 8. Any questions? Let me know. Hello? Yeah. Okay. Great, great, great. Okay. So that is why this webinar is live. I mean, yeah, layer 1, layer 2, layer 3, layer 4. Yeah. Okay. In Gempy, you give points that define the bottom of every layer. Yeah, that is an input, but you don't give only the points, but you give the orientation, that is the perpendicular. Okay, if you give an orientation for every point, it's too slow. I mean, the code is too slow. But since there are the layers, well, are somehow sedimentary, it is not so critical to it is not that critical to put all the orientation where it will be critical. For example, if you have a fault, for example, if you have a fault here, you have to give the orientation of the fault, otherwise the code cannot define the fault. Or for example, if you have a syncline, you have to put the orientation here and here and here. Okay, so that is why. Okay, so in this case, since our layers are almost horizontal, well, not are sedimentary. Okay, so we are not going to take that much attention to the orientation. Okay, if that understood is, please type 8. Great, great, great. So that is the orientation. Okay, and even that we only get for these 3 points of the 8. Okay, we only gave every 2 layers. Okay, because we are more interested that the code actually will run. Okay, or will run in less amount of time. Okay, and then we create a data frame. This is the data frame of the orientations. Okay, and then we export it to the CSV. So if we go to CSV, we have the model surface and the model orientations. Okay, great. So that is great. So let's go to aquifer.hatariapps.com. Let's go to sign in. Okay, if you have any model, delete it. Okay, and now let's see model. Okay, great. Let's go to edit and let's open a containerized apps. Okay, let's open that. Let's create a pod because actually this has a say this one creates a on session for you, and then we can go to view. Okay, if you are here with me, please type 9. If you are here with me, please type 9. Great, great. Okay, which is the x min? This is the x max. This is the y min. And this is the y max. Okay, the set min is 60 and the set max is 150. Okay, great. If you are here with me, please type 1. Okay, and the resolution is 50, 50, and 50. I don't know. Okay. Great. So you can you run it with resolution of 100? Sure, you can do it. Okay. Can you run it with resolution of 25? Yes, but you have to take into account which will be the resolution of the geological model and the resolution of the groundwater flow model. And that is another topic. Is in this case, what you are intended is to have more cells in the geological model, or that the cell in the geological model will be smaller than in the groundwater flow model, because what we do is the media of all the values that a cell intersect. Yeah. Do you want that I explain that in a graph? Please tell me yes. Please tell me no. Okay, great, great. That is amazing. Let's see. So this is your groundwater flow model. Yeah. And these are points that come from the geological model, where you have the X, Y, Z, and the little. Okay. Then you have 1, then you have 3, then you have 4, then you have 5, then you have 6, then you have 1, 2, 3, 4. What is our intention is that you have, okay, that the resolution of the geological model will be slightly smaller, slightly smaller than the resolution of the groundwater flow model, because we want at least one point of the geological model that intersects into our groundwater flow model, to a cell in the groundwater flow model. If you have it, like if you have many points here, yeah, you can have a better resolution, but the computational time and the resources will be much higher as well. Okay, so that it will be, for example, if the groundwater flow model has a resolution of 50 meters, the geological model has a resolution of 45 meters. Okay, if you have understood that, please type 2. Yeah. Okay, 50-50. Okay, if you get the cell size here, you will see that this is slightly smaller than the groundwater. Okay, so we only have one strata group. Okay, select. So insert the orientation. You don't have to do anything, because actually this will come from the CSV, the model orientation that we have just created. Okay, upload. Okay, and these are the values. If you are here with me, please type 3. Next, insert 0.5. Okay, it's model surface. Okay, so these are the 0.5. You don't have to do anything, and this is amazing. I mean, okay, and then here we have layer 2, layer 3, layer 4, layer 5. This is 1, 2, 3, 4, 5. And this will be of the group 1. Okay, if you are here with me, please type 4, 4. Great, so that is amazing. So let's see, let's continue. Load. Okay, then you have the point of the orientation, then you have the structural frame. Well, there is only one group, but if you have many groups and then you have faults, this will be interesting. Okay, and then we have some plots. Okay, yeah. Things to say. I did this software, okay? I work with a friend with Jose, in order to virtualize like this, okay? It works with 50 cells for every, I know that it works for 50 cells in the X, Y, and Z direction, okay? So that is 125, 50 times 50 times 50 is 125,000 cells. I know that, okay? If you want to work with higher amount of cells, it is better to download the project and run it in your computer, okay? Because otherwise the size of the containerized is not that it's not that powerful. It's not suited for bigger calculations, okay? Yeah, that is up to you. Okay, so but in this case it works here, so we are going to interpolate. Please interpolate. Okay, and the interpolation is running on the background. Okay, so now it has finished. It takes around 10 seconds. Okay, if it has finished for you, please type 5. If it has finished for you, please type 5. If you have any problem, okay, this is my WhatsApp number. Please tell me if you find any error. Yeah, if you have any error in the on the screen, let me know, because maybe I can give you a hint. Okay, there is 2 people that are following here. Daniela, Mohammed. If you are here with me, please type 5. Mhm. Great, Daniela. Who else? Great, Valentina. Okay, well, let's see. Then we download the, okay, first let's go to the, if you were able, let's go to Gempy app and let's delete this on the webinar, because we are going to place it with our own Gempy app. Okay, we have deleted that from the webinar folder. Yeah, and then we download we check the results. Okay, then we check the results. Okay, and on the result, this is a Gempy log file that says, okay, it has to say generate VTK time span of the VTK generation, and it says successful Gempy run. Okay, if it has said successful run, means that the actual Gempy run has created all the required files. If that is your case, please type 6. If that is your case, please type 6. Who else? Okay, okay, okay. Yeah, start again. And for the ladies that were here, okay. Well, Let's see. If you are here with me, please type 6. Yeah. Okay. We are going, please, on your download folder, in your download folder, just make it clear. Okay, just make it clear. And then download the project. Download the project. Download the project, and this will be appearing in your download folder. And zip it. I use WinRAR in Windows 10, I guess. In Windows 11 is somewhere else. Okay, and then I have unzipped it. Okay, and it will appear the MNT. Okay, the MNT inside has the Gempy app folder. Let's do Control C. Let's do Control C. If you okay, if you are here with me, please type 7. If you are here with me, please type 7. Okay, great group, and I hope that Muhammad can join us soon. Okay, so let's copy the Gempy app, Control C, and let's place it under the webinar folder, Control V. Okay, great. That is everything that you have to. Okay, because here, well, these are the Gempy folder, but the notebooks will connect to that. Don't worry. Just to mention that you can also see some plots, okay, here on the app as well. Okay. So let's see, and let's go to okay, let's go again, and let's open this foreign scripts. Let's open the part 2. Yep. Kernel clear all outputs. Kernel clear all outputs. Yeah. In this case, we are going to work with PyVistas. If you want to, you have to pip install PyVistas as well. Okay, so here you have FlowPy, NumPy, Pandas, JSON, OS, and PyVistas. Okay, we import this. Okay, and then we are going to import from the Gempy app, from the image data, the lithology.vtr. Okay, that is an output from the code that we have created. Okay, so we run that. And this of a rectilinear grid, because there are many points in row, columns, and layers. The shape is 125,000 cells. Okay. Well, this is a Python thing. These are all the methods related to this data set, to the rectilinear grid. And then we get the center of all the sets, and this is an array for all the center of all the sets. And then as well we get the values. Okay, we got the values for all the sets. Okay, if you are here with me, please type 8. Okay, and now we create, okay, now we have a JSON file. Okay, now we have a JSON file that is on CS in ref data. Okay, and the JSON file, yeah, is a, well, it's actually a, this is a visualization of the JSON, but the JSON is this. Okay, it's a file, it's a dictionary that has, for every layer has a value. In this case we have 5 layers, but there is the number 6. Okay, and why is the number 6? Because basement is a default unit in Gempy. Okay, because you have all the layers and the basement. Okay, great. So that is why here we are going to open the little. Okay, but we are going to insert the 7. And why is the 7? Because there are some places, and I don't know why, that were not identified neither as layer 1, layer 2, layer 3, layer 4, layer 6 as the basement. Okay, so in this case those values are number 7. Okay, so that is why here we insert a new, but we are going to repeat the values of number 6. Okay, and then we create an array. Okay, that this is an array that instead of being a little code is actually a value of kx. If you are here with me, please type 9. Okay, who else is here with me? Please type 9. Great, great, great. So then we are going to, well, we are going to reshape this. This is just a reshape because this is a thing of shaping, because we are going to join the x, y, z and the k value. Okay, so that's why we do numpy with each tag. I'm really sorry because there are a lot of things though. Okay, I hope that you are getting this step by step. Okay, unfortunately there is not that much time to explain everything. Okay, but here you have the x, y, z, a value of the little code, and then we save that as a CSV value. Okay, we do that as a CSV value, but we are not, because I tried to insert it as points in Model Muse and it didn't work. Okay, so that is why instead of inserting that as a point, I insert that as a shapefile. And by inserting that as a shapefile, it works. Okay, so that is why we create a data frame, and I'm not interested in certain values of the basement because the basement is the default value. So that is why we only go to say all the points that are of cell values number less than 6. Okay, 1, 2, 3, or 4. If you want to insert just one type, you can do it as well here by tweaking this. Okay. Any other questions? If you are here with me, please type 1. Okay, and then we set the CRS, and then we create, well, we create a shapefile, xyz.shapefile, and this will be stored on shapefile folder. Okay, it's taking some time. It's taking some time. Okay, so, and let's see, let's go to ref data, and here on shapefile you will have the xyz. Okay, that is the shapefile that you have created. Okay, great, great, great. So now let's open the Model Muse. Let's open Model Muse. Well, if you have it open, and let's go file, import shapefile, file, import shapefile. Then we open the XYZ shapefile, and then it's important because there are around, there in the beginning there were 125,000 cells, but with our query we have 86,000 cells. So okay, if you are here with me, please type 2. If you are here with me, please type 2. Okay, just to mention that we have a coming course, databylabs.com. Okay. Yeah, and this is a course on seawater intrusion, and this with MODFLOW 6, Model Muse, and FlowPy, and it's live, and this is next October. Okay, so if you are interested, or if you have any colleague that will be interested, because this is a live course, okay, So you will have questions and answers live, and this is based on the latest development of MODFLOW 6 that can model variable density flow. So it's my advice that if this is your topic or is related to your topic, take this course, okay? Otherwise you are going to see that just a recorded version of this, okay? That is great. Okay, that is great. Okay, so let's go back to Model Muse. Let's go back to this. Okay, we are going to set the value of intersected cells. Ah, okay. Where is? Ah, okay, okay. Sorry. I will fix this. It's in October. I will fix this. I will fix this. Okay, Jadon. 6 months. Okay, great. So let's see set value of intersected cells. Okay, on the set formulas will be a elevation. Okay, so set one formula elevation. Okay, and on data the k value will be directed to kx. Okay, so what we have done, one elevation k to kx. Okay, great. If you are here with me, please type 2. If you are here with me, please type 2. Okay, now is okay, it comes with, it's important. Okay, actually the data set is really heavy. Okay, the data set is really heavy. Yeah. Okay, it's really heavy, and it's not worth to see the points because there are many points. Okay, you can get it lighter. You can get it lighter if you can get it lighter if you just insert one geological unit, but we have inserted 5. Okay, great. Okay, nothing happened. Okay, but if you go to, okay, if you go to data visualization, if you go to data sets, to require to hydrology, then you plot kx, then you can plot it with light blue to that, to blue to gray in log transform. You will see, you will see that the geological units are there. Okay, again I did data visualization kx and so. Okay, if you are here with me, please type 3. Great, Jadon. Who else? Great, Mohammed. Who else? Okay, so who else is here with me? So the data set, the points are actually, I don't know why it's always tricky. The data sets are here, okay? This is the, but it's too heavy. I mean, it's too heavy to plot that on the Model Muse, so that is why I only get the representation. Okay, you can work it out with simple models, okay? But we have, by having two people that nobody else, if you were here, please type 3. If you have any questions as well, I mean, this is a live experience, so just do your questions. I mean, why? And it's free. just, just make your question. Okay, and then you can pass through the you can see, and then you can go through all the. Okay, nice, huh? Nice work. Distributed geological units in your model, okay, for free with only free software. Okay, so that will be. Do you have any questions? Please tell me. Do you have any questions? Please. Otherwise, if you don't have some questions, if you were just following the video, don't worry. If you just were following the video, don't worry. Just to remember that this will be in a week, some weeks as a tutorial, and later on available in our Patreon site. We have a course that is coming, and I will. You don't have any other questions, and I will stop the recording.